factoring by grouping is going to occur when you don't necessarily have a familiar trinomial or binomial to factor. So sometimes you're going to have to do some rearranging, but you might end up separating it or grouping it in a certain way such that you can pull away certain factors in common. So I can take away an x from the x squared and from the xy to produce this. Plus, notice I have this plus here. Now I notice these both have a common factor, a 7 and an x plus y. Now I'm noticing that I have sort of two terms, an x times x plus y and a 7 times x plus y. You could also think of this as I have like x times blob plus 7 times the same blob. So I could potentially notice this is a common factor and I pull it out to the front. So what this blob is really is x plus y, and so what I am distributing it to, or reverse distributing it from, is the x plus the 7. So my original 4-term x squared plus xy plus 7x plus 7y factors into x plus y times x plus 7. And this process is called factoring by grouping, and it requires a strong emphasis on reverse distribution. One of the reasons why we emphasize it during our isolation problems. So looking at this one, you might wonder, well, how am I supposed to know how to group it? Great question. You have to group it in a way that everybody's got some common factor times something, and some common factor times the same something. So this has to be the same, or some factor times that same thing. And sometimes it takes quite some renegotiation and rearranging, but let's see. For this, I'm going to group these together, and I'm going to say, oh, I can just take out an a and get an a plus k. And so for this binomial, I'm going to just remove a b and get an a plus k. Cool, I like the fact that the a and the k are repeating. I'm really hoping this is going to be an a and a k too. Yes, it will. I'll take a 7 as my common factor. So now I have this a plus k as my common factor. So I'm going to remove a plus k as the common factor, and what's left over is the a, the b, and the 7. So this 1, 2, 3, 4, 5, 6, this 6-term second-degree polynomial factors into a binomial times a trinomial. I make a note to see, can I simplify these at all? I cannot. Sometimes the way it's presented, there's nothing that you could possibly find in common with these ones. Okay, so you might have to rewrite them and rearrange them. So I'm noticing both of these have a y, both of these have a 2. So I'm going to bring the 2 and the 2x together, group them. There's an addition sign between, and I'm going to bring my xy and my y together. Now I'll factor these and hope that I'll observe a common factor. I have an x plus 1 and a 1 plus, oh, they actually are the same. Cool. Sweet. So I'll factor out the x plus 1, and my remaining terms that I would distribute to are y plus 2. And that is factored. Trying to figure out, do I need to do some rearranging? These both have a b, so if I factor out a b, I'd get a plus d squared. These both have a c, so if I factor out a c, I get d squared plus a. Plus, a lot of people forget that, so I could get d squared plus a. That's my common denominator that I factored out, and I get b plus c. Cool. I wonder if there's a different way to have gone about doing that. Let's just keep this as my answer up here. What if I wanted to like combine these ones? What if I did d squared times a b plus a c? And now this AB and the AC, right? Now I'm going to combine these. So if I factored out an A, I'd get a B plus a C. So I get A times B plus C plus D squared times B plus C, which would give me B plus C times A plus D squared. Is that the same as this? Yes. So it's rare, but it's nice when you're factoring by grouping and it actually doesn't really matter which ones you group together. One of the hardest kinds of factoring by grouping is when you want to notice that it's a PST, a perfect square, minus another perfect square, and it ends up being a mega dots. This is 2x plus 3 times 2x plus 3. So that will produce 2x plus 3 squared. So I have a perfect square right there. This is also a perfect square. This is now a dots. A mega dots, but a dots. So I'll take 2x plus 3. That is the first part of both of my factorizations. I'm going to have a plus and a minus, and then I'm going to have a 9y in both. I do want to reflect, can I simplify these? 2x plus 3 plus 9y. Nope, can't do anything with that. 2x plus 3 minus 9y. Nope, can't simplify that. This is the factorization. Here's another situation where I have 6 terms. I am thinking, I wonder if I'm going to factor that into 3 sets of 2 or 2 sets of 3. So maybe would I put these together and these together? Well, in this case, let's keep things simpler, and I'll notice I can factor out an a plus k. I can factor another a plus k, and here's another a plus k. Cool. So my a plus k is my common denominator. I have an a b, and a 7 that I would distribute that to.